Hello and welcome to the webinar Microscopy for the Incubator, Remote Cell Culture Imaging and Monitoring with zenCELL. First of all, I will introduce the two main protagonists for today. Number one, the zenCELL. The zenCELL is an incubator microscope with 24 miniature microscopes integrated into one device. And then there is me, Matthias Schuh. I'm the product manager of the zenCELL. And I have worked a couple of years also in cell culture laboratories. And this is why I want to introduce you to the advantages of cell culture monitoring remotely with an incubator microscope. I've prepared a short agenda. First of all, I'll introduce the zenCELL as your solution for microscopy for the incubator. Then I'll briefly touch on two application notes, one about cell culture quality monitoring and one about wound healing assay applications. Then I'll cover what's next for the zenCELL, and I will also show a startup showcase from the startup NeuroLab. And last but not least, our call to action from the zenCELL team, because we are here to help you to achieve your best cell culture process as possible. Microscopy for the incubator. Leave your cells where they belong. Maybe some of these scenes are familiar to you. This is, I guess, a standard routine in, I think, all of the cell culture laboratories worldwide. And during my cell culture training, I once learned that cells do want to see their master every day. Don't they? Or does the master want to see them? I guess if you're a cell culture specialist working with cell cultures day and night, you really build a connection to your culture, to your sample, because this is the accumulation of a lot of your work. The current run for a new vaccine, for example, or a new evidence generated for cancer treatment, perhaps. This is why we want to have this very delicate system working as properly as possible. And this is why we try to care about them a lot. But what we forget is that if we are the scientist that is manually handling single vessels at the microscope, retrieving them one by one from the incubator, this will mean we are accessing the incubator several times and thereby disrupt the incubator's atmosphere, increase the risk for contamination, and also disrupt the perfect incubation settings for the cell culture. Furthermore, we are spending a lot of time and also money, here in this picture, for example, on disposable clothing, to get only a single snapshot at the cell morphology. So, shouldn't it be the other way around? We should, I think, be able to monitor our cells every day and every time we want, but with comfort and all the negative impacts I described earlier. So the question is, do you want to scrub in to your clean room every day and handle single culture vessels? Or do you want to also check your culture, for example, while drinking a cup of coffee? And I think most of us want to be the scientists that can remotely monitor the culture vessels in the incubator and will not influence the incubation of the samples negatively, and can even achieve parallelization of experiments through continuous monitoring and analytics, and thereby even generate more insights at the same time. So, if this makes sense to you, I think the question is, what are the steps to remote monitoring heaven? Well, okay, I'll tell you. Obviously, first of all, get a zenCELL, then install it in your incubator and enjoy the monitoring capabilities. And this all can be achieved typically 45 minutes after you unpack our device. What else can you expect? First of all, the device is very compact and easy to handle. It is so small that you can easily fit several of them in a standard 180 to 200 liter carbon dioxide incubator. The device itself contains 24 miniature microscopes. And then you can decide with what standard culture vessel you want to use it. We have several adapter frames for the major brands, so you can use T25, T75 flasks, and even, for example, 24 well plates, in whom you can monitor each of the single 24 wells separately. And by using our software coming with the device, you can configure automated long-term monitoring, and you can utilize the integrated algorithms for image analysis. Especially these are of more interest, I guess. What you can see here is your new digital microscope view. You can see in the middle the overview of the zenCELL software, where you can see the 24 tiles which represent one of the 24 microscopes each. If you double click on it, you will get all the time series data that has been recorded for one microscope. So you can get all the single pictures and even play this as a video. And you can also get a graph plot of the algorithms output in terms of cell count and cell coverage. And the beautiful results are time-lapse video like this that can tell you a lot about your cell culture. What you can see here is a record taken over about 80 hours with the zenCELL monitoring our AL929 fibroblast culture. As you can see, we can easily monitor and see the cell growth and how our culture is developing and covering more and more surface of the area we are watching at. So how can you apply this system in your lab to take advantage of these benefits? Well, I prepared two basic application scenarios. Application scenario 1, the research facility. The task here is our customer is performing assays to test inhibitors for certain toxins. And for him, morphology and the structure of the cell layer are an important indicator to prove the efficacy of an assay, hence an inhibitor. The team, before they introduced the zenCELL, was faced with a problem. A typical experiment run would take between 12 and 18 hours. And there was a certain time frame where they had to record the proper pictures with the microscope to show the significant effects that they wanted to prove. So all their schedule revolved about these experiments, and this had the result that people had to come in on the weekend or at night to take pictures, or that even experiments had to be postponed to another week. After they introduced the zenCELL, they can utilize the time better and even generate a higher throughput of their experiments, given the automated monitoring with the OL. They now don't have to care if someone is in the lab to take pictures, because the OL will take care of it for them. The next application scenario I call the GMP or clean room environment. Our customer here is applying regenerative medicine approaches based on mesenchymal stem cells isolated from a patient's bloodstream. Without the zenCELL, they currently have to perform manual microscopy, and therefore this requires the lab personnel to scrub in and out of the clean room several times a day. This leads to a high consumption of single-use clothing and is a very time-consuming procedure. Imagine the time you take to scrub in and out of a clean room, plus the procedure of manual microscopy. The customer is currently testing out the zenCELL in an initial IQ, OQ, PQ phase, and they identified the potential to significantly reduce the access to the cleanroom facilities while applying the OL, which will lead to a cost saving in consumables, and the lab personnel, the professionals, have more time which they can put to a better use. Application note: cell culture quality. Application note: cell culture quality. Cell culture quality monitoring is very important to achieve reproducible results and experiments. And we believe that this quality monitoring should be non-invasive, automated and remote, and you should even be able to utilize 24 microscopes in parallel for that. Because significant, valid, and objective experiments require consistent cell culture quality. First of all, first piece of the puzzle is obviously that critical process parameters during incubation maintained on the inside of an incubator are stable, and they have to be as stable as possible. So it doesn't make sense at all to remove cell cultures from the perfect environment because it disrupts the climate in the incubator and also the climate in the culture vessel for the cells. And this is even more problematic for very delicate cultures that are cultivated under special conditions, for example, hypoxia, because these are even influenced more. So to avoid this disruption, monitor your cell culture and guarantee a good quality. You can use the zenCELL to record images and take care of this analysis. Just another example. What you can see here is a picture taken with the zenCELL as part of the time-lapse video file that is automatically generated for one well. For each of the microscopes, you can activate the analysis of coverage and cell number. And this can be visualized in a plot below the image/video. You can also separately analyze the data from the image analysis algorithms. You can also take this and export this from the software to use this as a tool to describe your processes and compare your processes between different experiment runs. A more detailed example is given now. What you can see here are 4 snapshots taken with the zenCELL from one well of a 24 well plate. The first snapshot was taken very early, about 24 hours into the cultivation. As you can see, we have a lower confluency in cell coverage. The cell coverage then rises up to the point of 36 hours to about a coverage or confluency rate of 70%. And then, after more than 72 or 96 hours, we can see a full covered surface and the so-called plateau phase. What can you take from these readings generated with the zenCELL? First of all, you can analyze the incline of the cell coverage developing over time. If your culture is performing as an experiment before, this is a very good baseline to see that growth rates are staying the same, which is an indicator that your cell culture is behaving as before. Furthermore, as you can see here, if you reach the plateau phase, this is something you actually want to avoid, especially if you're not sure if the effects, the inhibition effects that come with direct contact of the cells in a monolayer will influence the assay you are performing. So what you can do next is then to detect the perfect time and point to start your experiment or introduce a next step of your assay. Application note: wound healing or scratch assay. What is a scratch assay? It is an essential tool to analyze cell migration and already a common standard method in many cell culture laboratories worldwide. You're creating a cell-free gap in a confluent cell monolayer by manipulation or physical exclusion. And then the dynamics of migration of cells into the cell-free area are monitored. And in some cases, even while they are exposed to external stimuli or internal stimuli. For example, by adding a drug that will positively affect proliferation or maybe even inhibit proliferation. One of the important factors you want to calculate during a scratch assay is the so-called T1/2. What we can do with the zenCELL is that we can monitor and analyze every picture taken and calculate the cell coverage percentage of the area we are monitoring. So in this example, we have just done this, and here are 3 example pictures below the graph on the left-hand side. And you can see that the cell coverage percent is rising from about 50% to a little bit over 80, below 90%. You can then take this information and match this to the relative gap area and how the relative gap area is shrinking. And if the area has reached 50%, this is exactly the time where you can grasp T1/2 from the data set. So this allows you, with the data being recorded from the zenCELL software, to easily calculate this important factor. It makes it possible for you to compare experiments to this calculated factor. And remember, you can do this even 24 times over if you use a 24 well plate within the zenCELL. So you could run 24 scratch assays in parallel and easily gain more insight through this high throughput screening approach. And since seeing is believing, here another short video of how cells are migrating into a scratch recorded with the zenCELL. And as you can see, you can really witness how from the edges of the scratch, cells are migrating into the cell-free area. So, what's next? And our startup showcase. I'm very happy to talk about the upcoming features. I believe in the lab of the future and that it's going to be also a remote lab of the future. This means we will use resources that are maybe not even in the same country or in the same continent to perform experiments. And tools like the zenCELL that enable remote monitoring and deliver something tangible to you are a very important part of that. So next to improving the software features and the performance of the overall device, we are investing heavily in bringing features like a OPC UA interface, a Zila 2 compatible driver, and uplink to cloud services to the world of the zenCELL. We believe that in a automatized and digitalized world, interfacing is what creates new benefit for the users. and for you. And one of the services we are currently working to uplink to is a cloud service called NeuraLab, and the founder of NeuraLab, Jonathan, will now in the next couple of minutes introduce their cloud-based image analysis solution.
Hello, my name is Jonathan and I'm a software engineer at NeuraLab. In the next 2 minutes, I would like to give you an overview of NeuraLab. We provide an easy-to-use cloud-based solution to analyze cell images. These here are the cell images I want to use in my demo. These are intoxication examples of HeLa cells. I want to locate the position of the cells and differentiate between the different cell types, rounded and flat. First, I open the NeuraLab webpage and click on the login button to open the app. You are now at the dashboard view. On the left, you can manage and keep track of all your experiments. For this demo, I create a new one. In order to analyze our example images, we need to tell the system in which features are we interested in. You could click on this Create Prediction Model button here, and the system would guide you through this process step by step. But I did this already in advance for you, so we can choose an already existing model. I use this one, which distinguishes between rounded and flat cells. On the right side of the screen, we can keep track of all the images of our experiment. I can now drag and drop the cells images of my experiment here. We support other upload integrations as well. Here we can see now a list of all the images. NeuraLab has automatically counted and labeled the cells for us. I click here to open one. You can inspect the cell image, and you see that the results are looking pretty good. Here we see a flat cell, and here are some rounded cells. In the end, you can download the results via an Excel export. Well, this concludes my short presentation. If you are interested or have further questions, visit our webpage or get in touch with us. See you.
Before coming to an end with our webinar, a final call to action for the remote lab. We want to see more and more people benefiting from the features and advantages our zenCELL incubator microscope can offer to a cell culture laboratory environment. So please reach out to us and tell us our story, and we will make it possible that you can experience the zenCELL in your lab. So if you want to profit from automated and remote cell culture monitoring, then reach out to either me, Matthias Schuh, or Regina Lang. Regina is our team's biologist, and she will be happy to discuss with you certain applications of the zenCELL in your lab. Also, do not forget to visit our homepage, zenCELL.com, for the most recent information. Looking forward to meet you soon in person. With best regards from the whole zenCELL team, Matthias Schuh. Goodbye.